Hi everyone, so now I'm going to talk about a problem called Course Schedule 2. If you haven't seen Course Schedule 1, take a look at the playlist of graphs. I have made available a video where I explain how to go through the FANG interviews in the most efficient way possible. So there are thousands of problems. I'll explain to you the best problems, the best book that I have used to pass those interviews. So without further ado, let's take a look at the problem at hand. So Course Schedule 2 basically is very similar to Course Schedule 1. What we do is we have a list of courses. The first one is the course you want to take. The next one is the prerequisite. This basically means we want to check if there is a cycle in the graph. But differently from Course Schedule 1, this problem will ask you to return the ordering of courses you can take to finish, like from beginning to end. So to take course 3, you have to have finished both courses 1 and 2. And to take courses 1 and 2, you have to have finished courses 0. So he wants the topological sorting of your program. So how do we do that? Same algorithm we have been using so far. So this template, memorize, look at the GitHub available at the description because it shows up again and again. So we have a visiting set, a visited set. The only difference with Course Schedule 1 is now we have an answer array. So this answer array will be returning to give us the sequence, the topological sequence of courses we have to take. Very similar to Course Schedule 1. So let's take a look at this using the debugger. So we have that sequence of courses. We're gonna run the debugger. Oops, I put at the wrong spot. Let me stop. Oh no, it was the right spot. So let's start again. And we're gonna step into the code, take a look at the variables to make sure we're doing the right thing. So we start with visiting, visited, courses, and we will create a list of course codes, which basically will have all the courses that we're gonna loop through. Now we're gonna create the graph. So this graph basically will show the prerequisites. So here we have the prerequisite of 1 and 2 is 0. The prerequisite of 3 is 1. The prerequisite of 3 is 2. So now we can use that as a graph to see if there is a cycle. So now we're going to call the has cycle function. So the has cycle function uses that template we've been talking about for a long time. So if the node, so we keep visiting nodes and we put these nodes we're visiting in a visiting set. So if we're currently visiting this node, node 0, we return false, meaning we've already visited that node, so we have a cycle. But you can see that visiting just started, so we're gonna add 0 to that graph, and we're gonna recursively call with all the neighbors. So let's take a look. In the graph, the neighbors of 0 are 1 and 2. So now we're gonna call with 1. 1 is not in the visiting set. So we add that to the visiting set. Now we're gonna explore 1's neighbors, just 3. We add 3 to the visiting sequence. Let's see now what are the neighbors of 3. 3 has no neighbors. So what's gonna happen is that we're gonna return, now we start appending the values to the answer. So 3 is one of the answers. We return true. Now 1 is one of our answers. So it's basically popping the stack. We return true. Now we are gonna explore one of the neighbors and we're gonna put 0, 2. So 3, 1, 2. So observe we're doing this in reverse order. So when we finally return, I'm gonna return the inverse. So this is Python for returning the inverse. And finally, we're gonna print the sequence of courses that we want. So this code is available on my GitHub, which is on the description. So play with it. The best way to learn, in my opinion, is to play using the debugger than trying by yourself without looking. See if you can get the same result. And that's it, guys. So keep on the lookout for new graph videos that I'll be posting, and take a look at the video where I explain how to study algorithms on the description. So see you soon.